All right, so we'll give this a shot. First off, what we're learning today and for the next couple of days is called stoichiometry. So stoichiometric calculations. From the mass of substance A, you can use the ratio of the coefficients of A and B to calculate the mass of substance B formed if it's a product or used if it's a reactant. I don't know if that makes a ton of sense, but essentially every time we do one of these problems, I'm going to give you a certain mass of something and ask you for the mass of something else. And to do that, we're going to use balanced coefficients. Those coefficients, I told you the other day, they have another name that starts with M. They're moles, all right? Moles will always be our middle step that we will always take in order to do these problems. So what we will do, if I have to get A to moles and B to moles to convert them, the first thing you have to do is divide them by their molar mass. And the last thing you have to do is multiply them by the other molar mass. It will sort of make sense. It's a very easy process that we just repeat the same way over and over and over until it becomes ingrained and sort of automatic. Do you think it was automatic last year? It really is not that bad. So let's go ahead and jump into this. And of course, my slate is not in the mood to work. Neither am I, but I will anyway. All right, so let's go to this next page. It was already the one showing. This is just awesome. All right, there we go. We'll turn this off for a second. All right. So this is the exact style of question. I did not mean to misnumber that. I made 3, then I realized, oh, hey, I need a 4th, and then Rollins came up, and I obviously forgot to change the numbers. But it's 1, 2, 3, 4. So first off, you have to balance the reaction. So you really, in order to do well in this class, you have to be pretty dang good at balancing reactions. All right, let's see if this will work better now. All right, so write this down and then balance it. Take about 30 seconds to do that. You probably already did because it was up there before. All right, double check that we were streaming. What I should have done is required the host of kids to all sit on the same benches and take one of my iPads or whatever and stream. Have to be their phones, I guess. And they could attend class while on the bus. How cool would that have been? All right, this one I hope wasn't too hard. You had to take this 2, put it right there. That means you needed 2 right there, right? And a 1. Okay, I'm going to put these outside this circle. All right, so now that's the first step. Hopefully you are proficient at doing that. The next step is to find the molar mass of the needed species, and that's just a fancy word for whatever's involved in the chemical reaction. You okay with that? Sometimes they'll use the word reagents, but that usually refers to reactants, but it can refer to everything. All right, so I'm going to need the molar mass of Na because it gives me sodium right here, and it asks for salt. So those are the 2 species involved in this process. Are you all right with that? So this was 23 grams per mole. When you do this, you can round pretty, like, it's not like combustion analysis where you need to be really accurate. if it's 22.98, certainly I'm okay if you write 23. Then when you add the two pieces of Na and Cl, so you had 23 plus 35.5, that's our 58.5. Are you okay with being able to find those numbers? Okay? If we divide this up into little parts, it's not that bad. And make sure you know where you're getting stuck so I can help you out of that. But hopefully those weren't the worst things ever. All right, number 2, this is really number 3, and this is number 4. Number 3, set up picket fence with given number and unit at the top left. So you look up at your sentence, you're looking for the given number, that's 60. I'm going to thin my pen up here. You are given 60 grams of what? Of sodium, which is what symbol? Na, right? Okay, now, some of the greatest weaknesses of an AP student is that they are smart. And they don't want to do things my way. They think, well, that's just dumb. Like years ago, Mr. Rasmussen, he's here, his son wanted to prove how good at math he was, so he took the AP test with no calculator. I've already told you this. He's a mega genius, but he got a 2 because you can't do some of the math unless you know how to do logarithms in your head, which I don't, and I've had a lot of math classes. Like you can't do, he was a moron because he was so smart. Does that make sense? Please do it my slow way at first, at least, so that you can get good at it before you try a shortcut. All right. So what number 4 is saying? Move the given unit down and right until you have the unit you want. This is the process that I call the picket fence. So what unit do I want in my answer? Grams of salt, which is G of NaCl. All right. So now I know where I'm going to start. I know where I'm going to end. So now I'm just going to fill in this little road map we call the picket fence. So I need to get rid of grams of Na. So I come down here and I put grams of Na. Then I'm going to look up here and I'm looking for one of these ratios. I guess I didn't include the symbols, my fault. Which one has grams of Na? The 23, obviously, right? So you put 23 grams down here, but the 23 grams is attached to something, and what is it? Per mole, and it's 1. I should have put 1. So on top, you put 1 mole. Now, a lot of kids get hung up with the fact that I just flipped this over, and in math, that seems like I did something wrong, doesn't it? It doesn't matter in science. I need grams on the bottom to get rid of grams. If I wanted to get rid of moles, I'd put moles on the bottom. I can use it whichever way I want to solve whatever I want. All right, now, man, I'm getting lazy, I guess. 1 mole of Na was attached to the top. Do I want mole of Na in my answer? No, I want grams of Na. So what unit has to come down? Mole of Na. Now, oftentimes, this might be the step that kids get stuck on, but you don't need to. This is the bridge where we go from what I'm given, which was Na, to what I want, which is NaCl. And the only time Na and NaCl talk to each other are with these numbers right here, because that's when they're both in moles. So stick with me. There is a ratio that says for every 2 moles of Na, I can produce 2 moles of NaCl. Are you okay with that step? That's where you switch from given to wanted. All right, now, do I want moles of NaCl in my answer? 1 second. No. So I put 1 mole NaCl down here. and I look up at this ratio, and what is tied to a mole of NaCl? 58.5 grams. Now, I'll get you, Caleb, I promise. The units cancel. Grams of Na are gone. Mole of Na are gone. Mole of NaCl are gone. And I'm only left with grams NaCl, which is what I want in my answer, right? Now, mathematically, this step 2 over 2 is useless. Scientifically, that step is hugely important. So now, really, all you have to do is take 60, multiply it by 58, and divide it by 23, because the 2's cancel each other out. Okay, go ahead. That's fine. So if this was a 3 and a 1, you just put a 3 and a 1. It's just, this system lines everything up the right way. And it's not the only way, but it's the more, or it's the less perilous way. How about that? You're less likely to make stupid mistakes if you're a good accountant when you do these. And this is our balance sheet. This is how we're going to keep track of everything we're doing. So now, remember the picket fence. Anything that's on the top, you multiply. Then listen carefully. Anything on the bottom, you also multiply. And then you divide both answers. That makes sense? If you have a graphing calculator, or one that has parentheses, I should say, just put all the top in one parenthesis, then divide and put all the bottom in one parenthesis. But don't go a step at a time. That will screw you up. All right, I have no estimation on what this would be. What did my answer end up to be? What? 152? Everyone agree with that? Okay, 0.6. This doesn't seem like the worst thing we've done all year, does it? It would if it was the first thing. Maybe it's a blessing that combustion analysis is so easy, or not easy, so early. Because then you're like, well, I don't know what I'm doing, but at least it's not that crap. All right. Are we okay with the process? We're going to practice. Here we go. How many grams of iron are required to produce 80 grams of iron 3 oxide? Now, here's the problem for some of you, and I know you. You can do the math, but you can't do chemistry. So let me help you. How many grams of iron are required to produce? So iron would be on which side of the arrow? The left, right? And what am I producing? Iron 3 oxide, which is FeO. This is a plus 3 because of the 3. This is a minus 2 because it always is. So this is really Fe2O3, right? Is my equation valid right now? No. I didn't put this in the equation, but this certainly must be doing what? It must be reacting with oxygen. Then, do the rest. I think you can do the rest. Okay, so check that. Who thinks I have the right setup? Raise your hands. Okay, who has that same setup then? Same people, right? What's up? You two boys don't have this setup? Oh, okay. All right, so write that 159.6. That's when we added it all together. Okay, so what did we get? What was our calculator answer here? More than one person agree with that numerical value? We have 2, 3. Okay. Sounds not too bad, right? So to find 56 grams, we take, well, first I would reduce. 4 over 2 is really just 2, right? That'll save you 2 pushes of your calculator. So 80 times 2 times 55.8, and you divide that by 159. All right. Seems like it should be pretty reasonable. All right? Like sometimes you can, your brain, you can use that. 80 times 2 is about 160, right? 160 divided by about 160 is 1. So your answer should be close to 55.8, reasonably, right? And it was. So, hey, check mark. I encourage you in AP to check reasonability. Just think it through sometimes, because you can give me some really wrong answers that are super obviously wrong, but you just don't think it through. Okay, we all right so far? Let's do one more. This one, I'm not going to write the formula for you. So you got to come up with the formula of the stuff. You got to balance it. Then you got to do the stoichiometry. So you can check your balancing right there. Okay, let's wrap this one up. I don't know. What was the answer overall? Who has that? 67 point what? 167.9 grams of MgF2. Who had that? Raise your hands. Or close enough? Okay. So let's just double check in case you still are not with me. 65 grams of Mg. We need to get rid of grams Mg, so we have 24 grams of Mg for every 1 mole, right? All right, and then it was kind of nice. It was just 1 and 1. So 1 mole Mg to 1 mole MgF2. For every 1 mole MgF2, I had, what was this number? 62 grams MgF2. So there's nothing really to cancel out. So I just take 65 times 62 and divide that by 24. We all right with that? Who had this correct? Raise your hands for me. All right, nothing, Jack? All right. Okay, one thing I want to warn you about. None of you did it. I should have said this a long time ago. But when you find this number, you do not double it. Some kids will. This is a coefficient that's taken care of here. Don't take care of it here and there, and then you'll be all screwed up. Okay, so when you are calculating the molar mass, do not distribute the coefficient. Okay, who feels all right so far with this? Okay, let's pause for just a minute and let's do a homework problem and see how that goes, because it'll be okay. So let's look through this and just talk, and then we'll give you some time to do it. So hydrofluoric acid cannot be stored in glass bottles because compounds called silicates in the glass are attacked by HF. Sodium silicate, for example, reacts as follows. So this is a really complicated reaction. You don't need that paragraph at the top to do this. You just need these things. So for every 1 mole of sodium silicate, you react with 8 moles of hydrofluoric acid. That makes this complex ion. What would we call that? I can't remember. This thing right here is a complex ion that I cannot remember the name of. It would be silicon hexafluor something. It's not ide, it might be, but this would be an acid with that. I can't even name that. It doesn't matter, but whatever. And then you have 2 NaFs and 3 waters. So the first part, A, is less difficult than what we've been doing. says how many moles of HF are needed to react with 3 moles of Na2SiO3. So this is still a picket fence, it's just a shorter picket fence. I don't know if I'm going to like it right here, but we're going to put it right here. Anyway, I don't even think I need 2, do I? All right, so this is how you would do this. It's the same idea. This one's just shorter. So I have, my given is 0.3 mole Na2SiO3, or sodium silicate. And I want, what is my answer? Mole of HF. Is the word grams in anything in part A? No. If there's no grams, then you don't need to use the molar mass. You don't need to use the periodic table. You only use the balanced chemical equation. So what moles do I want to get rid of? That one. So for every 1 mole Na2SiO3, I need this many moles, so I need 8 moles HF. So I take 0.3, multiply it by 8, and I get 2.4 moles of HF. You okay with that? Okay. Part B. How many grams of NAF form when 0.5 mole HF reacts with excess Na2SiO3? So now I am going to need 1 grams, but not the other. Which grams do I need to calculate? This one, right? But it'll still be a shorter picket fence because I don't have to go from grams to grams. I go from moles given to grams wanted. Okay, writing small here. You can read that, is that right? Garrett, can you read that? You're the farthest away. All right. I like that you answered, Logan. Oh, are you? Okay, never mind. So, all right, what's my given? It is this, 0.5 mole HF. So I want to get rid of mole HF, correct? What's in front of mole HF? An 8 mole HF. What do I want to go to? I want grams NaF, so on top I must need 2 mole NaF. Then what do I need to get rid of? 1 mole NaF. And then I needed to calculate the mass of that. So I have Na, that's 23. F is 19, is that right? So 42 grams. We all right with that? All right, so really 0.5 times 2 is 1, times 42 is 42, divided by 8 is 5.25. Okay, now part C is the full gram to gram. So why don't you guys give part C a shot? Let's work through this real fast together. So we want to solve for, oh, I swear, I don't swear very often, but sometimes I do. Grams of Na2SiO3. This is called sodium silicate, right? So just for writing purposes, I'm going to call this SS. Now, you can do that too, but be careful. Make sure when you add all the parts, you remember it was Na2SiO3. How many grams of that can react with 0.8 grams of HF? So I start with my given, 0.8 grams of HF. What do I need to get rid of? Grams of HF. When I found that right at the start, we did it up here. It was 42 grams per 1 mole, right? So I put 42 grams, and it's always per 1 mole of the same thing. So what would I do on the bottom now? Take that over, right? What's in front of the HF in the balance reaction? Right there. 8, right? Oh, sorry, that was the NAF. You're right. Thank you. Sorry. I went to this one because I thought we'd already done it, but you're right, that was NAF. So that's just 20. I apologize. Thank you. All right, so what's in front of HF now on the moles? 8. What mole do I want on the top now? I want mole of my SS, which is really that stuff. And in my balance reaction, it was this 1. Oh, my poop. So 1 mole of sodium silicate. I still don't want moles, so I put 1 mole sodium silicate per every, what did this mass end up being for this? 122? Okay. So now I'm ready to do some math. 0.8 times that divided by all that equals 0.61 grams sodium silicate. If I ask you on the form to put this in, all I want is 0.61. It might say include a unit, but if I include a unit, I want grams. You don't have to type in sodium silicate. Just give me a number and a G. But I don't even think I asked for the G on that form. Has anyone ever, have you guys looked at that yet? Okay, how do you feel about this so far? Medium? Right? Right? Divide the two answers, yeah. Now, I would have done it different, but that might just screw you up. This divided by that is just 0.1, right? You with me? So, and I don't know, that might screw you up. So I would have put 12 over 20. I would have moved it over one. Like, I wouldn't recommend doing that, though. I've just done enough of these, and I try and eliminate. What I'm trying to do in my head is get either the numerator or the denominator to be one number, because then that cuts out a lot of stuff. But if you do that, there's landmines all over the place, so be careful on that. Okay, fist to 5-0, fingers if you're lost, 5 if you're fine. Raise your hands. Okay, so this is easier than combustion analysis, you think? All right. I don't want to move much farther on because people are gone. So what's the next homework problem assigned? 63 probably? Okay, so let's look. We'll do 63. Now, Caleb asked a very good question. Let me walk you through that real fast before we do this problem. Let's go here. He asked, how do you know when it's a long one or a short one? Like how long to make your picket fence. So let me talk you through this process just logically with no numbers, and then we'll talk about it. So the longest thing that we'll do is I give you grams, and I ask you to solve for grams. So this is the grams of what I give you, and this is the grams of what I want. You all right with that? In order to do that, we first have to convert the grams of given to moles of the given. Then we have to go from moles given to moles wanted. You with me on that? Once we have moles wanted, then we went to grams. Who's with me? Okay, so this long picket fence, that might be the best straight line I've ever drawn without the line tool. FYI, you witnessed it. All right, what we do, probably not going to work, yeah. These arrows, they are representing the vertical lines in our picket fence. So 1, 2, 3 of them to do this process. In the previous homework problem, the very first question, it gave you moles and asked for moles. So how many arrows was that? That's just one step, right? So that picket fence had one vertical line. The second question of the previous homework problem gave you moles and asked you to go to grams. So that was 2 arrows or 2 vertical lines. All right? So the length or size of the picket fence is determined by what is given and what is wanted. If you write this maybe down, it might help you to understand this process a little bit better. I don't know, you don't have to though. Okay, so here's 63. I'm sorry that they're so blurry. If you think about what this thing has been through though, it's amazing how clear it is. That is a low light picture on my phone on a textbook that's then converted to a PDF that then is uploaded, that then is screenshot, and then is pixel expanded magically. So it's amazing that we even know that it's a black and white thing. Technology, when it works, is when you know how to use it. All right, fine, I'm old. Okay, I'll pause this recording. Fire away.